Infrastructure as code for Azure ML is exam domain D1. 3, and it's where the MLOps engineers' DevOps skills show up. Bicep is Azure's native IAC language. It's more readable than raw ARM JSON and compiles down to ARM for deployment. For the AI-300, you need to understand Bicep structure and how it applies to AML resources specifically. The structure of a Bicep template relevant to AML has 3 parts. At the top, parameters and variables. Parameters are values you pass in at deployment time. Environment name, location, compute skew. Variables are computed from parameters, for example, deriving the workspace name from the environment parameter, so dev gets MLW AI-300, dev and prod gets MLW AI-300 prod. This pattern keeps templates dry. In the middle, resource declarations. The AML resources you'll define in Bicep are Microsoft.MachineLearningServices/workspaces. For the workspace itself, Microsoft.MachineLearningServices/workspaces/computes for compute instances and clusters, and Microsoft.MachineLearningServices/registries for the registry. Each resource block has a name, location, SKU, and properties object. The properties object is where you link the workspace to its supporting resources. Storage Key Vault app insights using their resource IDs, which you compute with the resource ID function. At the bottom, outputs. Outputs expose values after deployment, typically the workspace name, workspace ID, and resource group. These outputs get consumed by later pipeline stages. For example, after the Bicep deployment runs in a GitHub Actions workflow, the next step reads the workspace name output and uses it to submit a test job. Parameter files separate environment-specific config from the template. Your dev parameter file sets small VM sizes, 0 minimum cluster nodes, and public network access enabled. Your prod parameter file sets GPU VM sizes, reserved compute, and public network access disabled with private endpoint configuration. Same template, 2 environments, 2 parameter files. That's the pattern. The deployment command is az deployment group create-template file main.bicep-parameters. At dev.bicep parameter, the at prefix tells the CLI the parameters are in a file. Always use -what if before running in production. It shows you what will change without applying it. When a Bicep template grows beyond a few resources, you split it into modules, separate Bicep files that each own a logical group of resources. For an AML deployment, the standard modular structure has a parent template called main.bicep that calls 4 modules: workspace.bicep for the AML workspace and its supporting resources, compute.bicep for compute instances and clusters, storage.bicep for the data storage accounts, and keyvault.bicep for the key vault configuration. The module call syntax in Bicep is the module keyword, then a symbolic name for the module, then the file path in quotes, then an assignment block with a name, which is used by Azure as the deployment name for that module, and a params block that passes parameters from the parent into the module. The module's outputs are accessible in the parent via .outputs. Dependencies between modules matter because some resources must exist before others can be created. The workspace must exist before you can create compute inside it. Bicep infers some dependencies automatically when you reference a module's output. In another module's parameters, if workspace.bicep outputs the workspace ID and compute.bicep takes workspace ID as a parameter. Bicep knows to deploy workspace first. For less obvious dependencies, you can use depends on to be explicit. The existing keyword is useful when you're deploying into an environment that already has some infrastructure. For example, in a brownfield deployment where a key vault and storage account already exist, you use resource existing to reference them without redeploying. Resource kvm microsoft.keyvault vaults at July 1st, 2023, existing equals to name key vault name. Then you reference kvia.id in your workspace module parameters. This prevents Bicep from trying to recreate resources that are already there. The exam uses Bicep module scenarios to test whether candidates understand which resources go in which module and how modules pass data between themselves via outputs and parameters. Know the recommended module decomposition for AML and know how module to module data flows work.